And this is an interesting enough change from yesterday. Yesterday we finished the problem where we had a box hung on either side of a pulley. This is the same question. It's not any different. If this is box 1 and this is box 2, it's really not any different. So what I'd like you to consider is what would happen if there was a box on the table. Box 3. And for the time being, we'll make it easy on those of you who are still kind of struggling or who are going to tell me you're struggling. Let's assume that there's no friction here, but that's not going to last. All right? So you don't know which direction the system is going to go. You have to pick one. So work this out. Tell me what the acceleration is of the system. All right? So as a starter problem, since it's so similar to what we did yesterday, let's see. I chose to the left to be positive. That should be your answer. So the question begs, do you need me to do that? All right. What?
The G can be outside of the fraction, yes?
I'm not sure what you said.
Like, is the G outside of the fraction bar, have it multiplied by G?
So this is the same.
That is, okay.
That is the same.
Thank you.
All right, so if I need to work this one, I will, but how far did you go? You should have had at least most of the stuff we did yesterday. For example, M1G tension. M2G tension. You should have gotten that far. The issue is that this box here is experiencing tension, tension. And of course, M3G and normal force. Now, if those two tensions are the same, the box doesn't accelerate. The only way box 3 accelerates is if the two tensions are different. Since we're looking for an acceleration, there's no assumption that the two tensions have to be the same. It's two different strings, two different tensions. Now, there's probably a condition where those two tensions are the same, but it probably has something to do with the two masses that are being hung off the table are the same. But at this point, you should have three equations and probably a bunch of unknowns like T1, T2, and acceleration. Most of what you have here is the same as yesterday, though, so if you're struggling, what did you do next? If you can get this far, you should have M2G minus tension equals M2A. Any question about that? I'm not picking up anything weird here. This is the positive direction, so this direction is positive. Anything downwards I made positive, and anything upwards I made negative. Continuing that over here, this way is positive. So T1 minus M1G equals M1A. Box in the middle is experiencing two horizontal forces. So T2 is positive because this way is positive. I'm basing it all on this. Minus T1 equals M3A. And yes, normal equals weight. I'm not sure how useful that is, but I'll write it in there just in case you want it. So this is net force in the x direction. equaled M3A. This is net force in the y direction equaled 0. And look, I'm just putting all that up there for the benefit of the students who are still struggling a lot. But I think we're beyond this. Now, with that, let's bring it all together. You've got 3 equations that probably have stuff in them you need. You need to eliminate all the tensions here. Now, last class period and a little bit this period, I'm seeing quite a few people that are actually still actively trying to solve for t's. Stop that. I gave you a method that works better. Use it. T2 minus T1 equals M3A. M2G minus T2 equals M2A. And T1 minus M1G equals M1A. Look, if you want to solve these for T1 and T2 so you can sub them in up here, fine, but you're screwing up your signs when you do it. I am amazed at the number of people who cannot solve this for T2. It's bothering me now. Meaning you solve that for T2 and your answer is wrong because you've got the sign screwed up. And at this point, I don't even want to know who you are because that really will bother me. But also, I've got some folks who don't know what to do to get A by itself if it's on more than one side of the equation. I was talking to a student last class period who had this. Now, they had mistakes here, but they couldn't solve this for A. If this is you need to fix this. And I don't want to do all the math. I don't want to go back and teach you, math from 3 years ago. But you have to get this onto the same side with the other A. And factor that A out. That's your method. But you can't divide by M2 and think that's your answer. And like I said, if that's you in this room, fix it. Come see me when I'm not in front of the class. But I'm just going to add these up because I have a positive T2 and a negative T2. Those will cancel out when I add them together. And I have a negative T1 and a positive T1. They're going to cancel out when I add those together. And I get M2G minus M1G on the left side and M1 plus M2 plus M3 all times A on the right side. Pretty straightforward, solve for A. This is the starting point. This is not the ending point. So let's say that there is a coefficient of friction here. You give it a tap so the box starts to slide this way. So that's the initial velocity of the box. Kind of have to give you a velocity so that we can have a point of reference for friction. So fix this. What's the acceleration look like now? I ran the problem for you. This shouldn't be a hard fix. What will it look like now if there's friction in the problem? You don't have to change very much. Just looking to see if you guys can adapt and apply what you just were given. Because we're going to get to the hard one after this. It will cause a change in my sum here. So I'm now going to have M2G minus M1G minus mu M3G. That's the only thing that adding friction does. And like I said, if you want, you can factor out the G's. It doesn't make the problem better, but it does give you something about dimensional analysis that I think is appropriate. Everything in the top is in kilograms, right? Mu has no units. So it's kilograms minus kilograms minus kilograms on top, and the sum of 3 things that are in kilograms on the bottom. So everything in the parentheses is a unitless quantity. So my units are whatever the units of G. So that's an advantage, perhaps. Different things. Let's go back to this picture. I'm going to do the same thing, but I just want to clean this picture up. I'm going to get rid of that box that's on the table, get rid of the coefficient of friction, and just have the two boxes hanging on the sides. They're nice and clean. All right. Assume M2 is greater than M1. What's an expression for the tension in the string? Now, stop for a minute. I want you to think of something for me, because it's going to come up. If both of these boxes were the same mass, if for a moment both of the boxes were the same mass, and I said the system is at rest, I'm hanging two boxes, one on each side. What would the tension in the cable be now? I'm going to give you two answers. You pick one. Which answer do you think is right? A or B? No. I'm trying to trick you. How about this? You can hide it. A 1 or a 2, and you just hold up your fingers right in front of your face so I can see. That's all I need to know. So just tell me, is it 1 or is it 2? Pick one. If you hold nothing up, I think less of you. I'd rather you pick at least one and have an answer than be indecisive and pick nothing. And switching them makes you look even worse in my eyes. I think we're pretty evenly split, 50-50. Interesting. All right. So here's the ridiculousness of this question and why it's so easy to get right, but also so easy to get wrong. It's got to be this one. Has to be. Look, just think of one mass by itself. It's pulling down with mg. How much force has to be upwards for it to stay there? mg. That's got to be the tension in the cable. It's not a trick, but your gut is like, well, I'm hanging two masses, so it's 2 mg. Is he trying to trick me? Nope. I am not trying to trick you, but I think you'll be tricked. That's why what we're going to do here is important. I want you to find the tension in the cable. Assume M2 is greater than M1. I want an expression. And the reason I want this expression is because it's a mess, and you need to clean it up. This is an algebra problem. This is not a physics problem. You've already done the physics part of this problem. What I mean by that is you know the acceleration. I don't want you starting from scratch. Start here. Pick a side and find the tension. I only want M1, M2, and G in your answer. You have two places to begin here. So if you didn't know where to begin, that's a little frustrating. Because you had either T minus M1G equals M1A on this side. You could have used that, subbed A in here. Or you had M2G minus T equals M2A. You could have subbed the A in here. Pick one. If you didn't know to do that, that's a disappointment. And you can understand why I would be disappointed. But we can pass that. We can go on. Let's say that's what you did, because a lot of you aren't writing, which suggests that, okay, you did that. So what, Mr. Shelton? I still don't have an answer that looks like yours. Okay. So T equals M1G plus m1 times m2g minus m1g over m1 plus m2. Is that what you did? So get common denominators and add. This is a mess. Do some math and simplify it. You've been taught techniques for simplification. Use them. I would recommend that you get the common denominator of m1 plus m2, which means m1 plus m2 divided by m1 plus m2 times m1g plus, let's go ahead and distribute, m1 m2g minus m1 m2g over, oh, I'm sorry, I made a boo-boo, m1 squared g over m1 plus m2. There we go. So I just distributed the m1 in there. Still pretty ugly, isn't it? But you've at least got common denominators now. So let's handle the common denominator portion. I'm going to drag this someplace where we can see it. I'm going to distribute here m1 squared g plus m1 m2g, all divided by m1 plus m2, plus m1 m2g minus m1 squared g, all divided by m1 plus m2. I now have common denominators. I can combine my two fractions together. It's yucky, but this is how math works. I have m1 squared g plus m1 m2g plus m1 m2g minus m1 squared g. It's yucky, but those cancel. And these are the same term. They can be combined together, giving me a simplified term. Why is this important? Why should you do all of that extra work? That might not seem like a reasonable question, but look at what our original one was. Let me find it. There it is. m1g plus m1 times m2g minus m1g over m1 plus m2. It's hard to make any kind of reasonable decisions about what could affect the tension when it looks like that. I can make decisions easily here. This is simplified. A change in one variable is easy to see. A change in a variable here is harder to see. But also, think of this. We have a simple test to see if it's right. What happens when m1 equals m2? We know what the answer should be. When m1 equals m2, just get rid of those little markers here. That means they're both m. And the top is 2m squared g, and the denominator is m plus m, or 2m. No surprise, right? I'm not sure you can see that here. You can see that here. Now, look, this is a heavy lift. And will they make you do this on the AP exam? Sure, they could. This is just algebra. And all of this, 1 point at best for doing your algebra. This is just algebra, though. Some of you are scared of it. Get over yourselves. It's just algebra. You're not going to get any sympathy here. You know your algebra rules. Stop trying to make the whole thing fit in one line of your piece of paper. That's the biggest problem. Use the space. Now I have more I want to talk. Acceleration of this system is m2g minus m1g sine theta over m1 plus m2. That's assuming there's no friction. You should contemplate this both with and without different versions of friction. There's one more thing I want you to do, and it's because I forced sixth period to do it, that I think you guys should as well. And I don't want to spend very much time on this. This is an algebra exercise. It's not a... I think I have to do